The next topic we're going to cover is properties of logarithms. So this is section 3.3. We're still looking at exponential and logarithmic equations, expressions, etc. So the goal today is for students to be able to apply the properties of logarithms to keywords here, expand and condense logarithmic expressions. So we're going to be doing both of those, expanding and condensing. Now before we begin talking about properties of logarithms, I would actually like to review properties of exponents, because we can draw some parallels between these properties and the properties we're interested with logarithms. So let's just write these down real quick and see if that makes sense. In this case, we're going to use the letters B and then capital M and N. All of these are just any real number. Although B is going to be the base, so we do have a couple of restrictions on the base. Cannot equal 1 and it's greater than 0. Okay, so if we have b to the power of m times the same base to the power of n, this is the same as taking b to the power of m plus n. Because there are mb's in the first part and then nb's in the second part, when you multiply them, you're multiplying m plus n number of b's. Next, if we're dividing these two expressions, b to the m divided by b to the n, this turns into subtraction. So you can write it as a single base to the power of m minus n. Part of the reason you can do that, this is kind of a bonus property, and I talked about this a little bit in a previous video. This actually equals b to the negative n. So whenever you have a negative in the exponent, you can flip the line with it. And then the last one is when we have b to the m, and then that is raised to the power of n. So that means that b to the m is going to repeat n times. And so when you rewrite this, you can write it just as b to the power of m times n. So these are the properties of exponents. You've probably seen them at some point in your math career, but it is good to review those. So now let's talk about properties of logarithms. Now these are going to be slightly different, but they are related to the properties of exponents. Maybe we'll prove them someday, that would be fun. But not today. Today I'm just going to tell you what they are. So it's going to be very similar to what we see up here. So just like we have the first one, it relates addition and multiplication, the same thing's going to happen with properties of logarithms. We're going to say if I have log base b of m times something else n, then this actually equals log base b of m plus log base b of n. So notice if I have a single log on the left here, it turns into two logs on the right. So I have a single logarithm, and it splits into two. So this is somewhat similar to the exponent up here. We have 2 and then 1, but the plus and the multiplying kind of get switched. In the logarithm, we add the two separate logs, but in the exponential, we have a single base and the plus is up here. So it's a little bit different, but they are related. Okay, let's do the same thing for subtraction. So if I have m divided by n, or m over n, this works out to log base b of m minus log base b of n. And then the last one has to do with an exponential on the whatever's inside the logarithm. And then in this case, this is the only one that's really significantly different from the exponential situation. This n up here and the exponent actually gets sort of dragged over to the side and dropped out front. So this ends up becoming n times log base b of m. And so these are the three key properties of logarithms. There are some other ones that you might find if you Google the lists, but these are really the three big ones. The rest are kind of either not really, in my opinion, properties, or they just are derivations of these ones. All right, so let's see how we can actually apply these to some problems. So the first problem we're going to do involves expanding. And then we'll cover condensing afterwards. So for expanding, you usually start with a single logarithm. And end up with multiple logarithms. So for example, let's just say I said expand, let's do log, it doesn't really matter what my base is, I'll just pick something kind of weird, log base 5/4, just to show you it doesn't matter. And we're going to do 2 times, let's do x cubed times y. Okay. So notice here there's actually 3 separate terms. We have the 2 times the x cubed times the y. So each of those is going to get its own addition. We're going to end up with log base 5/4 of 2 plus log base 5/4 of x cubed plus log base 5/4 of y. And we're really close to being done. The only thing we have to do is handle the exponent on the x here. So the next step I'm going to end up with is log base 5/4 of 2 plus 3 log base 5/4 of x plus log base 5/4 of y. And that would be my final answer. There's really nothing else to do. We're not trying to solve at this time. That'll be the next section. We're really just practicing how we might expand and condense logarithms. Let's try another one just because I want to throw another kind of wrinkle at you. We're going to do expanding, let's say, log of, let's do a squared times the square root of c cubed all over b to the power of 5. All right. So notice how we're going to have to deal with this a squared, we're going to have to deal with the square root of c cubed, and we're going to have to divide by b to the 5th. So to set this up, I would probably start off by just breaking this up. Log of a squared plus log of the square root of c cubed minus log of b to the power of 5. So that's the first step, is to deal with those the multiplying and dividing. Excuse me. Now I'm going to deal with the exponents. So I have a squared here, I have a cubed here, and I have a 5 here. The problem is I also have this square root. Now remember, this gives you an exponent of 1/2. So that means I really have, instead of just c to the 3, I have c to the 3 over 2. So at this point, we can go ahead and drag all those exponents out. Log of a plus 3 over 2 log of c minus 5 log of b. And that would actually be my final answer. All right, so those are 2 examples for you of expanding logarithms. In the next video, we'll see a couple more examples of condensing and some further examples that you might see in Delta Math.